Pick myself up another oscilloscope because one cannot have too many scopes, and this one's going to be turned into a clock. Let's see what I got, and we'll check it out, see if we can get it working, and this will be part one of a couple parts to restore this unit. I picked up this really old Model 34 oscilloscope by Bell & Howell Schools. PVRI Institute of Technology, Bell & Howell Schools. Model 34 oscilloscope. This is a very, very basic scope, and the reason I was interested in this is I think this would be a perfect candidate to put. It's got a nice round tube. If it works, it's be a perfect candidate to put one of my little clock circuits, my oscilloscope clock circuits on, and turn this into a dedicated analog display clock. I don't know whether this unit works. I've not even turned it on yet. We're going to turn it on together. I'm going to fire this up using my dim bulb current limiter. As you can see, it's in current limited mode. As I turn it on, you'll see that the bulb glows very dim, so we're not drawing excessive current, which is good. Let's see if we get a display on here. Here's the scope. I've got it in XY mode now, I think, so we should just get a dot on the screen, which we do. We get a dot on the screen. Now if I touch the horizontal input, we've got horizontal deflection. Looks like the tube might need to be rotated a bit. It looks a bit crooked, doesn't it? If I touch the vertical input, we have vertical deflection. And there should be a sensitivity on here. There we go. So this might be perfect, but before I go down that road, I want to open this thing up and check it for those pesky, if there's any pesky paper capacitors in here, because it's old, it hasn't been used in years. Something probably needs to be replaced in here, but let's open it up and take a look inside the unit, see what tubes it's got. This is going to be a tube unit for sure, but it shouldn't. I hope it doesn't have tons and tons of tubes, because they're really not necessary for something this simple. A couple of amplifiers to drive the CRT and a power supply is really all that's necessary in here. The other one I've got, which is sitting on the floor below the bench, has so many tubes in it and cooling fans in it. It's an old HP. It makes enough noise to wake the dead when it's turned on. On the back here, we've got that's an adjustment on the back. That may be the rotation control, actually, astigmatism. And how does this come apart? A couple screws on the back here, and the whole chassis will probably slide out. So let's just unplug the power. These screws on the front hold the chassis in as well. Alright, screws are removed. The chassis should slide out. Now this is a thing of beauty. Wow. Couple switches. Caps on here. These are electrolytics over here, 20 microfarad 450. These are the ones that I'm most concerned with. But they're small, so I mean, you can probably change these out, no problem. 20 microfarad 450, there's 4 of them in here. And this one here's also probably got 4 in it as well. It's a multi stage capacitor. Let's just turn the unit on its side. I gotta be very careful with that tube. I do not want that tube to break, that's for sure. On the bottom here, we've got some caps here. These some capacitor, just these big electrolytics, which no sign of them leaking or anything, so they might be okay. I see some wax has dripped out of the power transformer, so that means that it's been hot at one point. It'd probably give you a good idea to swap out these caps that are here, these big electrolytics, at least get some replacements, and we'll just throw them on the bottom here and cut those ones off. I think that's probably the first thing to do, is to just eliminate these ones, because These caps here would have the biggest impact on that power transformer. If the caps were to short, for example, then it would overload that transformer. Oh, there's 2 more tubes in the back that I missed. There's 2 more tubes back here. So let's put a piece of tape around the tube here just to prevent it from moving and twisting and turning and so forth, because it's just held in place by this clamp, which is not very tight, and we don't want to put any excess stress on it, obviously, because this old tube here, if it were to break, there'd be glass everywhere. These are not pretty if they implode, believe me. Old tubes like this, when they imploded, they sent shards of glass everywhere. So you don't want to have one of these things break. That's for sure. Turn it back on its side. So one of these tubes here is the high voltage rectifier tube. Right, this one here is the high voltage rectifier tube. That generates the high tension for the CRT. 0.1 microfarads, 1600 volts. Right, these are very high voltage capacitors on here. And even my little breakdown tester would not be able to test these for breakdown because it only will generate up to 450 volts. Can certainly test these ones for breakdown, that's for sure. But this big one here, these ones here, no, they're just too high in voltage. Notice that the capacitors are manufactured by Bell and Howell schools. They made their own parts. Bell and Howell was very big back in the day. They made a lot of test equipment like them and Hewlett Packard. Right? They were very big in making this type of test equipment and running technical institutes to train new technicians on how to service equipment. First, let's see what voltage these caps run at. I've got some 400s here, but these are rated at 450. I want to see what they're actually running them at. I may have to get some bigger caps, which I'll have to do next week. Turn it on, and we'll just measure what these capacitors charge up to when they charge up. $447. So yeah, we're going to have to get the 450 rated. Because we got a lot of juice on here. 450 volts. See, rated at 450, and it's charging up to 449. 90 volts, 108, 80, 131. I can put regular ones in here. I've got some 400 volt rated. They work quite nicely with this one. But this one here, 155, 376, that's getting close to 400. That one will be okay. This one here though, at 448, that is going to need a 450 volt rated cap. We'll just let this discharge. See, tube circuitry is not as big and scary as people like to make it seem. See, these capacitors can hold their charge for a long time. Well, they actually discharge relatively quickly once the power is removed. Alright, so my 400 volt ones that I have, I can certainly replace these sections, but this one down here needs a 450, so I'm going to have to find a 450 for that one. So I found some caps in various old switching power supplies. So I got some 400s and I got some 450s. So I can continue, and we'll put the 450 on this one, obviously. Well, put the 450s on all of them. I got one that's a 200 volt, but that can go on that one because it's only getting 80 volts. So what I'm going to do is I'm going to put these, I'm going to tie down the positive side over to one of the other posts here that went to feed the capacitors, and then cut them off, like so that the internal cap is no longer available, because I don't want them to short. That's the big concern, is if the plates in these ancient caps were to short out, they could do some real damage to the rest of the circuitry. So let's rewire. I'll start with this. I'll start with the 450. We'll take the 450 and we'll put it across these terminals here. There's a 450 right there. So I can just put that 450 across those terminals and I'll eliminate that one. The other one, we'll disconnect this one here. We need to feed this wire up to here. That goes to the other side of this resistor. I got a ground terminal here I can solder this down to. So let me just cut that other wire out of there first of all. Get this 450 disconnected. Nice thing about chassis of this size is that there's lots of room to work in them, to add other parts and change things out. So the 450 is going to go right into here, and I'll just mount it right there on the chassis. A little bit higher in capacity than the others, but that's no problem. These are just basic filters, so once they charge up, there's no issue. The capacity being a little bit higher. So there's two of them replaced now. I've got to do the other two on this side, that one and that one, and I'll attach one of them right down here. And the other one goes between this resistor, and I'll probably attach that in here somewhere, maybe also to this terminal here. So we'll put one here. One can go right across that tab there, and then I can just move this other wire up to here. Ground over to this side. I'll just do that one when I do the other one as well. I'm going to remove this wire here. Remove these two wires. One of them is going right up to that terminal, so we can just cut this one off. And this other one I can move it over to the terminal that I just attached the capacitor to. Now I'll attach it right to here, solder this one down, and then the other one I can put across here, because this is an open terminal here, negative and positive, and then I can just connect this wire and this wire to that. So let's strip this wire back a bit. I know I've got wire strippers down here, but I just can't get them in there. Here. Okay, so we can take this resistor wire here. I'm going to cut this one. this wire down to here. For this other cap, it's going to go right there. It's going to go right through that one there, along with this other wire and another capacitor. So this wire can come out, and it can go also down to here, and then one more cap that will go in there as well. This is a 400 volter, which should be fine. So just take this one down in there. We will put it on this side. Get it away from hot parts. Put this one right in here. Like that. Okay, nothing's touching. That's good. So those 4 have been done. Now I just have to concentrate on the other 4 that are up here, which will also be relatively easy to replace. Find a place to put them. So first one I'll mount here. I'm going to mount the 200 volt one up here because this is only handling 80 volts. So, and there are some mounting holes in these lugs which I can attach the caps to, which is good. So you can attach that one there. And a bit of a hook in the end of it so that I can hook it through here and solder it down. Nice thing about having one of these high power irons, this is like a 60-watt iron, but it'll solder to these lugs really easily. It's got a lot of heat. Just like that. Position the cap out of the way, and then attach the wire to it, and attach it like that, and then we'll just put this other wire onto it. Cut that wire and attach it to the new cap. Same goes for the other one. Do this for the remaining 2 sides to this one, and that's really what I need to do initially on this. I don't know what these other caps, what shape they're in, but they're probably not as critical as these ones. The only ones that are really critical on this is the ones in the power supply, and that's just because a shorted capacitor could burn out the transformer. So we want to protect that transformer at all costs, because that would be an unobtainable part. And you can see from the wax that's dripped out of it that at some point it's gotten warm. I've got some leeway on the wires on this one, so I think I'm going to mount this one back here. There's a ground lug here. I'll mount this one here and then bring the other wires back down and connect them up down here in the middle of the board. I think that's probably the easiest place to mount this one because there's space here. and the wires for the others actually end up down on this side of the board anyway. They're the board, they send the chassis. So let's get some solder on this lug. And just put capacitors there. Then I'll bring the lower voltage of the two to the lower voltage cap, because this one's only handling about 80 volts, so this is coming from down here. Just pull this wire through. Which one is it? Is it this one? No, it's this one. That's the one there. So we'll take this one through, bring this one back and connect it to the 80 volt or the 200 volt cap. This is an 80 volt line. Yeah, it won't be quite as neat as it used to be, but it will do the job. We'll just twist this wire here and solder it down to this one. Do the same for the other. Dress the wires so that they're out of the way. I'm not going to contact something that's going to be hot. And same for this other one. Take this one, which is going way up here, and bring this one down to connect to this side of the cap. And now all four of the caps in this multi-can have been replaced. Now, any of these other coupling caps that have gone leaky, if they have gone electrically leaky, I don't know whether they have or not. You can certainly test these with the breakdown tester if we need to test them. But typically, if these were to go electrically leaky, we are going to see it on the screen, because it's going to drive an amplifier into overconduction. And if that happens, the trace is going to go off the screen one way or the other. We wouldn't be able to control it, because they'd be driving one of the tubes into saturation from one of the plate voltages from an adjacent stage, which would certainly show up on the scope screen immediately. So I'm not so worried about those ones being a problem. The electrolytics in the power supply, though, if these ones shorted, you wouldn't necessarily see it on the screen, but they would overload the transformer and could burn out the transformer. Not that this thing's going to be running 24 hours a day. I'm going to put the clock circuit on it. I might even just attach it to the back of it or somewhere else external so that it can be accessed. But I could put it inside. There's lots of room in the cabinet, of course, to mount the clock circuit. But I'd kind of like to keep it away from the high voltage if possible. But I think at this point it's safe that we can turn it on. I can hook the clock board up to it, and we can see if we can get a picture off of it. So I've got the scope plugged in. Here comes up our, see, as everything's warming up and everything's doing the dance. We can adjust our horizontal and vertical position, no problem. We can adjust the focus. I think that control on the back is the astigmatism. There's another control on the back here which can be adjusted. I think that's astigmatism back here. Let's see if we can turn this one. And that's exactly what it is. The tube itself is actually quite bright. This is a dark green glass. Let me get the little clock board down and we'll hook that up and see if we can get an image off of it. Well, it's working, it's just that it's inverted. My horizontal is backwards. Vertical is fine, but the horizontal is flipped. I have to invert the horizontal. I should just be swapping 2 wires on the horizontal plates on the tube. Should do that. Just got to figure out which ones are the horizontal plates for the horizontal deflection, or for the horizontal, yeah, the horizontal deflection. It's electrostatic deflection, but it'll just be switching 2 wires on the back. But that's not looking too bad at all. Breathing a little bit. I'm sure changing some of the other caps might help that too. Focus control. Anyway, let's work on reversing the tube, flipping the tube around, or the plates for the tube. Since there's no number on the tube, I can't look it up. Tracing through the electronics, though, it looks like it's coming off of this tube here. We'll see whether if I unplug that tube, whether that kills the horizontal. Then we'll know that that tube is driving it. And that tube comes up onto these 2 wires here. So switching these 2 wires around should create a mirror image. But let's just unplug this tube here first of all. I think it's this one here. And see whether that will stop the, because that's where those 2 blue wires come up, is here. This is a dual triode type tube. So if I unplug this one, I should have no horizontal deflection. So let's power it up. And when I touch this, I should get lots of horizontal deflection as the tubes warm up. Right? Now if I pull this tube, aha, no horizontal deflection. Therefore, if I switch the 2 blue wires around, either on the tube itself or on the back, I should, in effect, flip the display horizontally. Now I can either do it here or do it on the back of the tube. It's probably easier just to do it back here. So let's just cut these 2 and switch them around. Put that one onto this wire here. Put this one on here. Makes me nervous having this thing apart, just in case something were to fall from above, right? And will hit the tube. Some things are always falling off my bench, you know, bump something and something falls off my amplifier. So I want to try to get this thing back in its case as quickly as I possibly can. Makes me nervous having it sitting apart here like this, because if I break that tube, then this thing is shot. Okay. We'll hook up the time generator again. I'll do another test and see how it looks. See if the time is the right way around on it this time. So plug it in. Bring back the clock board. And power it up. And see whether it's the right way this time. Looks like it's the right way this time. Oops. Horizontal width. There we go. Yeah. It's looking a lot better. Still a little bit on the dim side, but it could be just the CRT is so old. I think if I took off this dark green, and of course we've got connection problems here. But it's working. Reseat all the tubes. I think I'll probably end up having to check and change some of the other caps that are in there. I'm sure that this is going to need all the caps changed. I'm going to end this one tonight. We've got it running. I don't want to run it any longer. I'm going to get in and change all of the caps. I'll have to order them in. And then we'll do another one when I change the paper caps and the other caps on the bottom here. I'll just take an inventory of what I need, and I'll get some of those high voltage caps, and then we'll change them out. I want to do that just to make sure that we're not going to cause any damage down the road due to leakage. I mean, it really is. There's not a lot really to damage on here, though. There's some 12AU7 tubes, but there's not really a lot else that's going to get damaged by some leaking paper caps, because the big ones of concern were the electrolytics, which have now all been changed out to new ones. But I think I'll get some of the other caps and we'll change them out as well and see if I can get this to improve as the tubes warm up. You see, here's as the 12AU7s are warming up. I wonder if I crank that all the way up and just back the size control down on this a little bit, because this can adjust the size too. Whoops. It's gotta. And I don't have a really good connection here as well. That's also probably what's affecting it, is my connection here is not the greatest. The fact that I'm seeing my focus shift, though, is indicator that something in the focus voltage is changing. So I think what we'll do on this is say change out the other caps. I'll show you the ones I'm going to change out on this one. We'll change out these 0.1 1600 volt. They're actually warm. They're probably leaking internally. I'll change these ones out, and probably these ones as well, just for the hell of it. That's an electrolytic that could be changed out. That's a lower voltage one though, but we'll change these ones all out. I'll just take an inventory, get what I need, and swap them out. These ones are probably okay. Ceramics generally don't go bad, but these ones certainly do. So I'm going to throw this together now just so that it doesn't get damaged. And we'll pick this up once I get some parts in. I don't know whether it's going to be this week, next month, 6 months from now. But we'll get back on this once I get some parts. And we'll get this one ship shape, as they say. Anyway, it was cheap. You know, you see people asking ridiculous amounts for this. This was cheap. So I took a gamble on it. Hopefully that transformer is not problematic with this wax leaking out of here. That's a good indication that this transformer has been hot. So I hope it's not something shorting in the transformer that's causing that focus to change, because that would be a real problem if it was. But we'll cross that bridge when I get there, I guess. We'll change out the other caps first and go from there. So this is what I need. I need 2.25 at 400 volt, 4.1 at 400 volt, 1.05 at 400, and 2.1 at 1600. And these are probably going to be the ones that are a little more difficult to find, but I will certainly make an effort when I'm down at the electronics parts store in town to look them up and see if they've got them. And we'll get that taken care of. Anyway, for now, there it is. I think I did okay for this. I only paid like 20 bucks for it, so I think I did okay on this one. And it should make a nice little display for my AVR clock circuit, which I've got 2 of them. I've got the other one is on my Tektronix XY scope. This will do great. I'll show you some of these tubes in here before I close off, because these tubes themselves were made specifically for this, right? Bell and Howell schools, original tubes, right? When's the last time you saw a Bell and Howell school tube? What is this one? DVRY, Tech by RCA. So this is an RCA tube, but it was made for them. A 6DT6. What is this other one in here? Another one made in the USA by General Electric for DVRY. Is it DVRY Tech? DVRY, VRY. I guess that's how it's pronounced. DVRY Technical. Another tube that was made for them. So this is all original. Very cool. There's another Bell and Howell. What is this one here? Another one that was made for them by RCA. Right? Again, all original tubes. These were Mallory caps. They're now, of course, replaced because they were electrolytics. Another one back here. This is, I think, this is a rectifier. This is a rectifier tube. A 6X4 rectifier. Another one. This is made by RCA. And then this is the little high voltage rectifier for the focus and stuff. The EHT. This is a high voltage rectifier tube. A 1V2. Sometimes we call these things X-ray tubes because they have a tendency to emit X-rays. But this is a high voltage rectifier. A 1V2, 1 volt filament. Again, made by RCA. And then of course the CRT, which I don't know what it is because the sticker is missing. But I'm going to close this off now, throw this together, and we'll pick this up down the road once I've got some caps to replace all the rest of them. I'm not going to bother with these ones here. These are just part of the time base as far as I can see. We're not going to use the time base, so we don't need them. In fact, they could probably even be disconnected. But I'm not too worried about those ones. I don't think we're going to have to worry. These are part of the time base circuit, which we're not going to use as an XY scope. I found the sticker for the tube. It's a Hibachi 5 UP1F. That used to be stuck on there. So until we get new parts to replace all the caps in here, thanks for watching. We'll catch you in the next one. Bye for now.